Hello everyone. Today we will be looking at changes in the states of matter. Before we understand the changes in states of matter, let me ask you a simple question. Have you ever wondered how an ice cube melts and gets converted into water? Or wondered how the same water can get reconverted into ice? Curious, right? Let us see how this works. On Earth, materials exist in one of three main states of matter, which are solid, liquid, and gas. The materials of all these types can be changed into solids, liquids, and gases by changing the temperature. Let's look at each of these. In a solid, the atoms are tightly packed together in rows and columns, and the bonds between these atoms are also very strong. And this is the reason all the solids around you remain in a fixed shape. If we look a bit closely, imagine the atoms in a solid vibrating. What if we heat this solid by raising its temperature and giving each particle more energy? The same particles are now vibrating even more, and now they have enough energy to break the bond between them. The bonds will break and the atoms can now move around much more easily. And now we can say that the substance will change into a liquid as the particles are moving around much more freely. This change between solid to liquid is called melting. Just the way we heated the solid substance, if we heat the liquid, each particle will again gain more energy and the atoms spread out even more and move freely. The space between these particles are very large and the bonds now are non-existent. And the change between liquid to gas is called evaporation. All the changes that we just saw can be reversed as well. If you observed a pattern from solid liquid to gas, the substance had to be heated. That is, there was an increase in temperature. And now, to reverse this, the substance needs to be cooled down. That is, a decrease in temperature. And one more change. On heating, the space between the particles got larger, whereas now on cooling, these particles will come closer together. Just take a moment to think about a cold can of soda on a hot day, those water droplets on the outside, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air cools down to form liquid droplets on the outer surface. Now imagine you take a glass of water and put it in the freezer. The water will quickly cool down and the liquid will now become a solid, and this is called freezing. Now coming to the last topic of this video, which is internal energy. We can understand that temperature is a measure of the average molecular kinetic energy of the particles in a system. This kinetic energy is distributed amongst translational motion, rotational motion, and vibrational motion. Just like the molecular kinetic energy, there is also molecular potential energy, which is the electromagnetic force acting amongst the atoms of an individual molecule and between each separate molecule. Now, the sum of all these types of energy that are exhibited by the particles is called the internal energy. It is denoted by an uppercase U. Internal energy is associated with atomic motion. It is also directly proportional to the temperature of a sample, which means that higher temperature means more internal energy and lower temperature means lesser internal energy. Through this, we can say that a substance does not contain heat. It contains internal energy, like the kinetic energy of all the particles. It is the transfer of energy from higher temperature to lower temperature which we call heat. Internal energy is an important concept in the study of thermodynamics, which is the study of heat and temperature and their relation to energy and work. So now let's have a quick recap of what we've learned so far. In summary, the physical state of a material is dependent on the energy given out by the particles. The more energy they have, smaller the bonds between them, and the more they move. Each particle has its own melting and boiling point. These are key temperatures where a material will change state between solid, liquid, and gas. The sum of kinetic and potential energy gives internal energy. Internal energy is directly proportional to the temperature of a sample, which means that higher temperature means more internal energy and lower temperature means lesser internal energy. Now you can answer the following questions to test your own understanding. Thanks for watching. Hope it helps you clear out your concepts on the states of matter.